Okay, so then let me welcome you officially to our one-day course of in, interactive visualization with Python. My name is Wandrille Duchemin, and I will be one of your teacher today. I am in Bioinformatics working in Basel, where my work is spread helping out various biologists with their research question. And in the course of this work, I need to be able to analyze their data, but then also to be able to share these results both with them and also to help them share their results with other. And to do that, I use quite a lot of visualization, and I found that using interactive visualization helped me quite a lot with data exploration. So that's why I'm quite happy to share these techniques today. And with me, I also have Jeffery, who will be teaching today. Jeffery, if you want to say
Hi
a few.
everyone, good morning and nice to meet you. I'm really happy to be here today. I am finishing my PhD in bioinformatics at the University of Freiburg. I've been working a bit with data visualization and how to create dashboards, mainly using Plotly and Dash, which are like the main tools we'll be using today. So yeah, I'm here mostly to help you in when you'll see in the agenda that we have some exercises. And I will also share with you some tips, some tricks, and some other tools that you can use and you can integrate to make your data visualization experience a bit more friendly.
Okay, thank you, Jeffery. You have received all this the URL to this Git repo. And so I hope that you have taken the time to grab the content from this repository. If you already were in our previous intermediate Python course, I know that you have, and I know that some of you were there. But if you haven't, please do so either by doing a Git clone or by clicking on this green button there and clicking on this download zip button there when the pop-up appears. That will download the whole course content on your computer. Then you need to unzip this file if you downloaded that as an archive, so that you can then open up a Jupyter notebook instance, or you can do that also with any other tools, such as, for example, VS Code does that without issue. And then navigate to where you have put this content. So here you have highlighted there. From there, you would go to the folder named Course 3. That's our third intermediate Python course. And here you should now see these flurry of notebooks, which is what we are going to be doing today. So as you can see, I have here two first notebooks there, which are about Plotly, basic and tricks. Then we have three notebook number 3. That's because there are the different Plotly project, and you will have a choice here to make. And then after that, we are going to discuss Dash, which is a way to sort of make more interactive web apps. And after this, we have the project here associated to that. So I'm going to start with the first notebook, and I'm also just going to click on that one and then just take a minute to make sure that you are all at this point, that you were all able to start this notebook, download the content, and so on and so forth. So I would please ask you to, yes, exactly like Hans, please use the reaction. Please put a little green tick with the reaction if you are able to get there. And please let us know as soon as possible using the chat if you are experiencing any issue. All right, because we want to make sure that you have the notebook that you can follow along and, well, do the exercise and so on. So, let's start with the basics of Plotly. So here we just want to introduce some basic syntax, okay, relatively high-level interface of Plotly, and a few of the principles. We are also going to try and look a little bit at what's under the hood, because understanding a little bit what's under the hood in Plotly figures help us understand a little bit then the sort of function names and how we can then play around more with these. So for this, of course, we need some data to represent. So we are going to use the Penguin dataset, which is a dataset that is nice because it's both relatively simple. It offers some nice visual pattern to visualize, in particular for scatter plots. Um, with still enough, let's say, enough complexity that we can sort of try and play around with a few options. So this is a data set of give or take 300 penguin, which come from 3 species. And for each species, we have measured both their species, but also you can see a number of measurements such as their sex, their flipper lengths. These Coleman lengths are something that are related to the beak of the bird, and then also some measurement of some isotopes found on them. All right, so there is a number of information there. And that's a data set that can also be used to do some simple machine learning training. But here we are going to use it just for visualization purpose, of course. Um, so you have here a quick description of the features of the columns in this data set. And we are going to start with Plotly right away. So here, depending on your version of Plotly, sometimes I've seen some cases where these two lines were needed, and sometimes they were not. So just to be sure, you can just run them. So this one is to make sure that Plotly properly renders on notebooks. Okay. Uh, so I'm just going to run this one. And then we import Plotly. So from plotly.express, we import it as px. That's kind of the classical way that we do that. So plotly.express is sort of the high-level interface, if you will, of Plotly. We will see after that a lower level, which is the graph object submodule. But here we are going to do that. And then we do our first call. And that's kind of the typical way that we call these high-level functions, is that we call a function here, and then the first argument will be the data frame, the typically a pandas data frame from which we grab the information, and then we map the different columns to different graphical elements. So here we say the X is my column length column, the Y is my column depth column, and then this creates a figure, and then I call this figure, and that shows the figure. All right. So now is the moment of truth. So if there were any problem with the installation of the notebooks or with Plotly, that's when you would start to see some issue. So if there is any technical issue at this point, please let us know, because we would want to sort that out as soon as possible. Otherwise, I will presume that this showed properly. I see that Walter has a little problem with the visualization. What is the problem, Walter? Okay, so uh, perhaps, yeah, okay. So we are using Jupyter Lab. You don't see the figure. Okay, that's problematic. Perhaps Jeffrey, could you try and sort that out with him in the chat or in the Google Doc?
Yeah, I
Okay.
can check.
All
Yeah.
right, but apparently you are able to use something to make these visual. Okay, that's
Yeah,
great.
so sorry. Yeah, it was exactly my next what I was about to say is to change to browser to see if it renders maybe outside to if it's able to render the picture or the figure with the browser. You can try
Okay,
that.
perfect. Thank you. And okay, and Dylan has an error as well. And all right. So perhaps Dylan, if you have the same type of error as Walter, you can try the same fix. And then otherwise, same thing. Don't hesitate to communicate in the chat. So perhaps Jeffrey can handle that while we continue with the content. Okay, great. So um, when we create this visualization, you see that we have just given X and Y, and that's what gets produced. And you can see that already there's quite a bit of stuff that's added on by default. So that's kind of the thing that are always there with all plots created by Plotly.express. So we see first off that we have our good old scatter plot. That part is not particular. But then in part, we see that when we hover around points, we have information that pop up. That's what we call the hover data. And we see that this hover data basically gives us the value for the X and the Y. Okay, so the Kalman length and the Kalman depth. Okay, all right. That's what we have. And we see that we have an hover behavior also that is about just the closer point, give or take. On top of that, we see that we have a number of buttons there. In particular, we can, you see here, we have the zoom tool. So you can sort of here select an area and then zoom into this area. All right. And if you double click, you zoom back out. You can also use this little zoom forward, zoom out. Okay. And you can also move to this tool to sort of pan around. Plus here, you can download that as a PNG. Sorry, and here you have this little button to reset the axis. All right, and you can look at all of these different buttons. So that's already quite a number of tools there that can help you out with exploration of your data. Okay, and it's kind of useful to know that they are there and to know how to use them because that's already something that can be quite nice. Here there is not too much point, but when you start to have many points with some area which are high density and so on and so forth, being able to zoom in, zoom out is quite a useful tool to have. And from here we can start, and before we jump into more complex stuff like adding colors, adding more element onto the plot and so on and so forth, we can start to see a little bit what's in this figure. So if we print the figure element, this is what we see there. So we see that it's a figure object. And you see that inside there are the symbol that let us know that there is something that is a dictionary, or at least that behaves like a dictionary. And that's actually a relatively complex. You see a lot of nested elements, but we have two main elements. The first main element is this data, and the second element here is this layout. All right. So this data here, it's basically what it contains all the things that relates to things that are going to be shown there, okay, to the information that are going to be shown in the plot. And it is typically composed of a list of what Plotly calls trace. So trace is basically it's like a layer of data. Okay, so if you have all of these points there, they are a trace. But if we add also a line on top of that, that would be another trace. If we had another cloud of point, that would be another trace. Basically, it's up to a point. It's like a legend entry, if you will. All right. It's not exactly true because there are ways to manipulate that around, but on a basic principle, that's kind of the case here of what a trace is. And you see that a trace presents itself as a form of dictionary again, or can be thought of as a form of dictionary. where you have a number of elements. So that's what the trace of what we are showing. You see here our X data and our Y data. You see that it is actually here the data is shown as somewhat encoded in a somewhat encoded form. You have here the data type associated to that. Depending again, perhaps on your version of Plotly, I know that on older version, rather than showing this encoded version there, you add directly the number showing up sometimes. All right, doesn't really matter in the end, but just so that you know that this is where the data is. And then you have other elements, and in particular, you can sort of see, okay, what is the type of this trace? That's a scatter. Okay, so that's indeed why we have called the function scatter there. What is the orientation? Vertical. What is the name of that trace that's useful when we start to do legend? What is the mode? It's marker, so that's why we don't have a line there, but we have different markers. And also you see here the marker color, the marker symbol, and you see here also the over template. So you see here this text here, you see column length and then this percent X and then column depth percent Y. So that's what governs what will be shown here when we over. And so from there, you can guess that actually this can actually be changed and manipulated by accessing this element, by modifying what's in the trace. We can actually play around with that. And we can do that either kind of directly, and it's something that is done, or we can do that with some function that lets us set up at the time of figure creation. And both are okay. In the end, what matters is really how you are able to access these different elements in the most efficient fashion. So that's our trace. And then we have the layout element, okay? And the layout is really about the rest. It's about the overall thing that are around the data, everything that is not the data in this plot, okay? And so in particular, you see here this x-axis and this y-axis part, where you see the x-axis is anchored on the along the Y. Okay, but you see that it's actually not mandatory because that's something that can be changed. The domain of it, so from 0 to 1, and so you see that it's not in data domains, but so not between here that what would be 12 to 22, give or take, but rather along this axis there, and that can be useful again to kind of sort of manipulate subplots or plots within plots and such element and such things. And the associated text here, for example, title text and stuff like this. And that's where we could also add more things such as changing the color of that thing, adding more things, changing the text that appears, and so on. So we have these two main elements there. Now we can try something which is to just add some color. And so for this, we see again that we have the same code. Okay, we manipulate the X and Y. And then I add a new argument, which is color equal and then species. So that's one of the associated, one of the columns of the data set. And you see that very, very naturally. Now this is what we get. So we have different colors for different species. So far, very, very simple. If you are used to something like Seaborn, or if you are familiar with R as well, if you know about ggplot, that's something that is also very, very easy to do. We have now 3 species, okay, so each point colored according to species. And we have now also this automatically generated legend where we have our 3 species value associated to colors. Now, in terms of interactivity, we have a few more things. The first is that we can click on an element in the legend to make it disappear. Okay. And we can also, and that's something that I find quite nice when I have lots of category, we can also double click on an element to make only that one show up. So if I double click on the green here, chin strap, you see that now all the other got hidden. And if I double click again, they all become visible again. That's also something that I find very useful in practice, yeah, when exploring data. All right. So we have that added, and we see also that now in the hover data, we see that we have the first line that now gives us the species as well. All right. So in general, by default, most of the thing for which you map to something graphical gets added to this hover template, so that you can have all of the information there. All right. And if we look now at what is in this figure, now we can see that we actually have more things there, because now in our data element, we have 1, 2, and 3, 3 traces. Okay, so we have basically 1 trace per species. All right, and so this correspond to this 3 legend entry. Okay, I told you traces correspond more or less to legend entries there. So we see here the one for the Adelie penguin. Okay, and that's actually in directly hard coded inside the hover template. And we have the entry for the Gentoo penguin. We have the entry for the chinstrap penguin. All right, and so that's the one thing that has changed. Right. Okay, so I just ask you for a few seconds. Sorry about this. All right, and so from there, you can see that already we have a, let's say, potentially interesting basis for a figure, and sometime when you do exploration, that actually might suffice for for your need. And so we have created a figure, and of course, this figure we can download it as a PNG, which is nice if you want to have like a fixed version of it, but you can also, and I recommend to often also export it as an HTML file. And so you can just do that very simply by taking your fig object and calling this write HTML thing. I find that quite useful because when you write it as an HTML file, I can see here, you see it's been created there. You have a file that is, you see it's relatively big, all right, 5 MB. And then if I start to have more and more and more data in it, this starts to get a bit big. But what is nice is that this is an actual self-contained version of your figure that can be sent to anyone. And because it's HTML and everyone has a web browser nowadays, they can just open it on their computer and they can explore the data themselves. You don't need to pay for a server. You don't need to care about hosting and so on and so forth. So you can just share it with anyone, everyone. Okay. There's a question by Balash. Can you export static image to JPEG or PNG, but rendered in much higher resolution? That's a great question. I must say, I don't know if you can manipulate the resolution when you export, because I think that this downloads something that is a bit default when you use the button there. But there might be a function to write there when you control that. But this I must admit that I don't know, so I'm going to make a little note, and during the next break, I'm going to look it up. All right, I'll make a little note. All right. So that's one thing I heartily recommend doing that. And so yeah, because for dissemination, to send that to colleagues and so on and so forth, that's quite useful, I find. All right, so we've seen that. What other option can be done is also to play around with symbols. So we can play with color. You see it here mapped to species. And then if you want to change which marker goes to what, this is the symbol option. So here we map it to sex. And so now you can see that we have by default the circle that is for female and the diamond there that is for male. You will see also that by default, because it likes to think in terms of trace, it will then make one entry per trace. All right, that means that you might have now 6 entry. One could want to have like two separate entry, but by default, that's what you are given there. If you want to separate them, you need to sort of work it out a little bit more exactly on how the legend is presented with respect to what the data does. And that's because of the inherent way that the figure object uses traces concept. Okay, and so you have one trace basically per combination of species and sex. And that is still quite useful because then you can relatively easily show and isolate each of these traits. That's what it basically expects in the creation of the figure. So far, so good? Okay. Yes, Jeffrey?
Yeah, regarding the question for exporting the image, yeah, it is possible, but not from the bottom in the graphical interface. It is possible, as you said, with a function. I will share a link on the chat if you want to check.
All right. So, okay. All right, great. Thank you, Jeffrey. So, so you see here, so far, so good. We are with stuff which is relatively simple. Ta, 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 ta. Oh, there is a great question by Walter. Can you share the HTML where there is a way to hide the data if you open the file like a TXT? I ask because sometimes I work with farm data. Sometimes I need to share maps, but I don't want to show the coordinate. As far as I know, Walter, unless you purposefully kind of recode them such that the number don't correspond to the number, so that you kind of arbitrarily change the underlying values, if you will, sort of a numerical encryption. Not really, no, because at some point it will be shown, so it will be kind of perhaps in this F8 version and so on and so forth, but at some point the number is there, and so unless you actually sort of encrypt it a bit, that will be difficult. I'm guessing that if you want to be sure not to show that, perhaps what you can do is do some sort of numerical transformation. So you apply some sort of offset and then some multiplication on the number to sort of obfuscate them a bit. But I would contend that anyone extremely motivated would be able to find back the actual original value if they put enough, let's say time on trying to understand that. So yeah, as far as I understand, it's kind of, let's say, open data in a sense. All right, so simple stuff. Now we have our figure element. So remember, if we do a print on our fig, right? Yes, yes, Walter. As far as I know, yeah, at some point the points are going to show there. So yeah. All right. So you see here that we have our elements, okay, that are there. And as I told you, we can set them up by just changing things when we call here this first plotly express function, and some elements are relatively easy to set up that way, but some other elements are easier to set up after we have created this base figure, because this element, as it's here in fig, it's still there. I can still do operation with it. I can change it, show it again, export it, change it again, and so on and so forth. And I can play around with the different elements, okay, by just modifying, accessing them. And so we can do that by just using a dot syntax. So for instance, you see I have my layout, and let's say I want to change the title text. So I got layout dot legend dot title dot text. Right. So you see I can go layer by layer to access the nested element here. And I set up this from species, comma, sex to species Latin name, for example. Okay, so if I do something like this and then show the figure again, I have now species in parentheses Latin name. So that's what I've changed there. All right. You can do that in this way, okay, with the dot syntax. You can also use the dot update layout, and then you give the element, but rather than using a dot syntax, you use an underscore syntax. So layer legend underscore title underscore text equal, and then that. All right. So that's two methods to do exactly the same thing. It's just that depending on the use case that you are at, sometimes it can be beneficial to use one over the other. I'm thinking in particular for if you need to change these, for example, programmatically, using this approach there is a bit easier to access programmatically, to make this change programmatically, because you just need to call update layout, and then you can automatically, let's say, deduce the name of the argument that you need to give there in order to make the change. All right. So that's one thing that helps out. Whereas if you need to change things, and especially if you are doing things a bit experimentally, I find that this method here with the doc syntax is a bit more useful for me, because you with the dot syntax you actually have auto completion. So you go fig dot layout dot, and then you don't remember exactly what you need, so you hit the tab key, then you can hover to legend and then title and then text. So it's easier to just quickly explore your option manually to have this option there. So it's useful to have both way of accessing things. And so from there, because as I said, nothing beats practice, we have a micro exercise. So your goal is to take this figure there. Okay, so you have just a fig, but now you want to modify it such that the x-axis corresponds to now body mass, and the x-axis uh, reads penguin body mass in gram. All right, so you want to make these two modifications. Um, so you can here, yeah, look a little bit at pretfig.layout to see a little bit how you can access this x-axis label. And so what I will ask is, when you do this micro exercise, when you are done with these two questions there, please put a little green tick with the reaction. And I say specifically the green tick and not the thumb up, because you might have seen the thumb up disappears after give or take 5 seconds. So please put the green tick so that it stays, and so that I can sort of see who's done with the exercise and who's not. So I can decide to make the exercise slightly longer so that it's shorter based on that. And after that, after you've put the green tick, if you have a bit of time because you're waiting for the others to finish, you have a little bit of extra work here by trying to make the x-axis label blue. It's a bit harder, but then that's why you are here. Okay, so I'm going to stop sharing and let you work on that. And all right, so let's look at the solution of that one together. So with the first one, we can just create a new figure, and now we need to change the X to the body mass. Okay, so X is body mass, Y is the Coleman depth, and color species. Let's go. You see that if I just do that, no figure shows because I just created the figure element but didn't show it. But I can show it here. And that's what we have there. It seems that if we look at body mass, now we don't see that much difference between Chinstrap and Adele. So next we wanted to change the x-axis title text. So you see the solution down there, see fig.layer.xaxis.title text, but I just want to showcase how I usually do that. It's basically, you might remember it's something that has to do with X, and then use tab to autocomplete. Then you are not so sure perhaps, so you can again use tab, but you will see that you have plenty of options there. There's a lot of possibilities there because there's everything that has to do with the x-axis. That can be useful to also explore the sort of possibilities that you may have, but there is so many options that it can take a lot of time. For things that are very simple and that are already, if you will, there, okay, we already have a text there. Often the simplest is to just go and do a little print of the fig. And so you can sort of see there that we have this X or Y axis title and then text. Okay. And so for this, we would go then to what we see there. We go with TY, and that gets us here this title. And then here again, you would see that we have a number of options there. And then we go to text and we can change the text. So it takes a little bit of, let's say, exploration, going around, fiddling, trying stuff, but usually we can get there. So we see that we can change it here. And now this here also, this part with the font, when we need to change the color, so that was the extra exercise. This one is a little added layer of complexity there. Often what I would, you know, advice is that you try to play around with that and to see a little bit what they propose. And so you can see here that indeed the title, for example, has a here font which has a color element. And so that's kind of one further layer. And so you can try and give it directly, or you can give it as a dictionary that maps this sub element to what you want. So there's again different way of going at it. But here, the way that they actually want you to give that is in this way. So this, you say that the title font needs to be a dictionary of different font elements. That can be the font type, the font family, and that also can be the color that you set up. So here we set the font to be the default font, but with color blue. Okay. Right. So this is a bit of a silly example there to change that blue, but that's also to kind of get you to see that all of these elements can be, let's say, explored and played around and changed. Okay. It takes a bit of time. I'm going to be very honest there. It takes a bit of time to sort of go there and see what are all the elements and then play around a little bit with them, try and see exactly what is expected there. But this is all sort of accessible, and it's always kind of this little dot or update layout with the underscore syntax and dictionaries element. So there is nothing extremely exotic there. It's always kind of the same thing. All right. So that's about this little exercise. So from there, we have, let's say, our basic element. Okay, we know that we will have a number of proxy express functions. So far, we have looked only at the scatter, but then later on, we'll look at line plots, box plots, and all sorts of stuff. But it will always be kind of this sort of thing. Then we have a basic syntax, which is that we give the data that we want to give, then we map something to the X and the Y, and then we map some other columns eventually to colors, to symbols, and to other elements. So now what we can see is how we can further specify what we give. Here I show first how to specify the color that we give. So there are several options for that. We have here the default color scheme, okay, which is very serviceable in a pinch. You quickly want to look at data, but then very often you might have your own color that you want to add, your custom color that you like to use. So this is the default scheme when you are using categorical data for column, and this is the one when you use something numerical, all right? So you see here this purple to yellow shift there. And from there are qualitative and quantitative palettes which you can choose from. That's the first option. So um, you have here this nice little function like this pix.colors.qualitative.swatches that show you all possible palettes. I find that relatively nice because then this lets you kind of choose which one you are interested in. And you see that they differ by not only the kind of feel that this color can give, but also by the number of categories that they offer, which again can be useful depending on the number of categories that you have at your disposal in your data. What's more, and which I find, you know, nice, is that you can look up the exact color type in case you want to use it in some other plotting software and you want to have the exact same color. So that's also a nice touch. So how we use that is with this px.colors, okay? So I say here, same thing as before, but I specify the color discrete sequence. So basically I give the palette here. And so that's a px discore qualitative. And then say, for example, what we go with this vivid part here. All right, so then that should be the first and then the second and then the third color. We see here that we have these three there. All right. If we are unhappy with that, we want to go with this antique. Messed up. We change it there, and you see that it's as easy as that. Not very nice color scheme there, but All right, so that's you see here relatively easy. You are still though bound to the pre-existing scheme, but that's a nice way and easy way to change things. Of course, from there, you have many other options. So it is always this color discrete sequence element. And you can also give a list of color, either this named CSS color. You have here a little link to all the color that exists, but it's mostly basic English names. Not everything is defined there, but you can see that you have a relatively nice set to choose from. And then alternatively, you can give the actual hexadecimal code for any color that you want. So if I now demonstrate briefly here, this brown, silver, chocolate, all right? So they are going in order, brown, silver, chocolate. Or what is even more useful, I find, is to give this color discrete, but now instead of sequence as a map, where we explicitly map the different entry there corresponding to this element in the species column to specific colors, so that you have now tight and explicit control specification on which category goes to which color. I personally find these quite useful. And so you see here that I actually now use the same color scheme as the one that we have in the nice little illustration up top there. Okay. Da, 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 da. Right, so that gives you now different options to do that with color discrete map and color discrete sequence, giving a list or a map. And then from there, to go with the continuous one, it follows very similar concept. So we have this px.color, and then we have different options for continuous. We have the sequential, the diverging, and then also the cyclical, which I here don't show, but because there is, I think, many. And so you have here this diverging. All right, so you see where we go to from one to the other, passing often by the white, okay, options. Then we have the sequential one, so we kind of go from A to B, okay, so from here, this varies so from purple to yellow, passing by green, and so on and so forth. So you see that you have here many options. So if you're somewhat familiar with some of the classical plotting libraries, you would have seen most of these, all right, and then the continuous are there also. right? So here it's then the same idea. You specify color, continuous, and so on and so forth. And then you can change your color scheme quite easily. Okay. So we see here that we have many, many options when we play around that. So that's for the colors. Then another thing is the symbols. So again, a few ways of doing that. One thing that I show there is how to just change all symbols. So here I say I define my basic plot, and then I update, but now not the layout, but the traces. And I set up marker symbol equals star, so that will change the marker symbol to all of them. Okay. So if you would remember again why I call that marker underscore symbol, is that if I again print my fig, sorry, up. Super, Dylan. Apparently it worked to install all libraries manually. So that's great. So you see here that we have this marker element. So in the data, so in each of the traces, we have one thing, which is a marker, and then we have marker color and marker symbol. So that's why I update trace. So I change what's in these traces, and I update the marker underscore symbol to reach this element. So again, you see this thing, knowing a little bit about the structure of how Plotly thinks about traces, thinks about the layout, helps us understand a little bit how we can actually access this thing inside. It's not just for the pure pleasure of torturing you with a complex nested data structure that we look at this. It's because that's actually quite actionable. So we can change all this to star. Of course, that's a bit silly, but why not? Then, of course, we have seen that we can actually associate a column to a symbol. And then that's where we can give a symbol sequence. So in the same way that we could have a color sequence, we can have symbol sequence, and we can also have a symbol map. So here, for example, star and circle, because the default is to have circle diamond. Perhaps we didn't find that so useful, so perhaps we want to have star and circle instead, and that's how we can get that. Okay. You have many, many different symbols at your disposal. Here, the code is extra ugly, so I spare that to you. It's just to show you the different symbols. Actually, that was grabbed from their little from their website there. And you see that you have a number of symbols there. Okay. So from very simple one, circle, square, diamond, cross, X, triangle, up, down in all sort of direction, pentagon, hexagon, and so on and so forth. All right. So you see many, many, many options there. And then for many of them, you have then the same thing, but if you just add dash open, you get the, for instance, circle dash open, you get the same thing but now in an open version, which sometimes for plotting it works better. And then you can also add a dot in the middle, and you can have open and dot in some cases. So you see that from there you have many, many options to choose from depending on which graphical feel you want to have. Using an open version sometimes can be useful when you have points that tend to overlap a little bit and you want to see them through the overlap in a sense. So then, yeah, from there you see that you can sort of choose what makes sense for your particular case. So that is to change our color and our symbol. So far, there is nothing that is too, let's say, different from what we can also see in other plotting libraries. Where we start to see some stuff that is more specific to Plotly is with the hover text. So we've seen that by default, most of what we put there will be reported in the hover label that is there. Okay. And that's something which we can play around with because we have different options for that. And the main one in plotly.express is over underscore name and over underscore data. So basically the over name will be just the name of this little pop-up there. So you see that now the species is inside the overing information, but also appears as title in bold above. And what we also have is this hover data. So we have added as data additional columns, if you will, the column sex and the column body mass to be shown there. So you see it's not in the X or the Y, so we needed to add it on top. And that goes in addition to what's already there, the color and the X and the Y. Right. So far, so good? Okay. All right. So already with this, we have a way to let's say, quickly do a relatively like informative over element where we can have plenty of information. We are still using something that is relatively default in the field though. So sometimes it's useful, perhaps if we want to have a more efficient exploration, to change a little bit the way that we actually show them, in which order, which one we show, which one we don't show. For this, we can play with hover data, and rather than just giving it a list of additional columns, we can give it a dictionary of what will be shown and how. So I show here silly example, but just to showcase the different options. The sex here with the associated to the true value means that it will just be shown as is. Body mass will be shown using here, we use an F string format. So that's basically here one number after the decimal, that's this dot one, that's what this means. And then in the scientific format, that's E. Here, four numbers after the decimal, and then in the float format. And then false means that I want to hide it. So true, show it as it is, false, hide it. So useful sometimes if we don't want to have too much visual clutter in this label. So we can just show what we want. So now you can see the column length is shown with four number after the decimal. The sex is shown as is. The body mass is shown in scientific format with one number after the decimal, and the column depth is not shown, right? So that gives you a number of options from which you can already kind of build a relatively custom over label there, so that you can help your user or yourself focus on what you want to show there and avoid too much visual clutter if you start to have many information there. All right. So now we have played with specific data element, the color, the symbol, and also the hover label. All right. One other thing that is also relatively classical is to change the overall figure feel, the theme, as it's called in other libraries, and in Plotly it's called the template. So you have a number you can choose from. Here I just change from the different options that are given to you from Plotly, ggplot2, and so on and so forth. And you see that I change them by just saying template equal template there. All right, so that's the template argument. So that's the Plotly default one, the ggplot2. All right, if you are used to R and if you want to make a figure that has the same exact feel, all right, for instance, to include that along others that were made with ggplot. Seaborn, if you prefer Seaborn. Simple white, Plotly white, so mostly that means with the grid. Dark version useful, in particular if you plan on integrating that somewhere online. The dark feel can be quite nice. Presentation mode. So the presentation mode tend to have a bigger label, bigger. You see here x-axis and y-axis label and so on and so forth in general, so that it's easier to see from afar. You have to be a bit careful then because that leaves less room for your data. But that's a nice way to, let's say, quickly make everything a little bit more zoomed in and more appropriate for a set of slides. So, for example, something like this. The grid's off, X grid off, Y grid off. grid with no grid, and so on and so forth. Okay. So you have a number of options there. I won't spend too much time on this. This really depends on your use case and what you like to have, but know that this exists because sometimes you could reproduce each of these by spending 2 days trying to find what are the different options to do this or that, or you could just find what is a template that works for you and be done in a few minutes. All right. Okay. And so from there, as I told you, we can move to many other kind of plots. So we now know that we create our figure, and our figure is a set of traces and a set of layouts. And then it's all about manipulating, if you will, these traces and layout, and then mostly also playing around with the Plotly express figure function, so that they give us already the correct good base figure type that we want to have, which will be easier to manipulate to the field that we want to have. I won't go and do a very long catalog here because I think that the Plotly documentation, I give you here the link, make quite a good work in actually making this sort of, if you will, catalog thing. But I still want to showcase a few of the main things that you will have to manipulate, that you want to use. And the first is perhaps this line plot. So we've seen the scatter, then of course comes the line. So px.line, you give something to the x, you give something to the y, and then the same thing, you can give the colors, you can give the symbols eventually, and you can also manipulate a little bit the here labels. So you see here how I can sort of play around with the hover template. So with the labels, I have mapped my X to T here, and I have mapped my Y to cos of T. So otherwise, by default, before we had the name of the columns that were automatically set up there, but now here, as we don't play around with the data frame, we would have by default X and Y. And so with the labels argument, I can sort of automatically correct that rather than having to manually then set up fig.layout.x-axis.text equal t and fig.layout.x-axis dot y-axis, and so on and so forth. All right. So the line, okay. One thing which I find immensely useful also with Plotly, and I think that's one of the reasons why I started to play around way more and more and more with Plotly, was also the 3D plots, and in particular the 3D scatter. Here, for example, this just Coleman length and depth and species, but now also with the y corresponding to the corresponding to sex. So here again, it's a little bit silly as a representation, although we could gain some information from that. But you have now a 3D frame that can quickly be moved around, zoomed in, zoomed out, and exported and shared with other, and so on and so forth. I personally used that a lot when I started to play around also with, for example, think about UMAP plot, or think about PCA plot, where you have many axes which represent some information. Well, very often there is interesting information in the further axis of the PCA, not just the first two axes. And so being able to do a 3D plot can sometimes yield very interesting insight in your data. So that's why I enjoy a lot playing around with this 3D scatter plot. So something to like to consider. And then also heatmap. So heatmap are a visualization what we use a lot in data science when we want to look, for instance, at the correlation between element, or just we want to look at some data very quickly. It's nice, but it's also nice if we can sort of now use also the over in function of this, and the zoom in, zoom out function of Plotly, because as soon as we start to have many data points, this can become hard to read or hard to get the details. So being able to over in and get the precise value out of there. Here we don't have that many points, but being able to zoom in there can be very, very useful. So definitely something to consider. And you see here also how I can change the continuous color scheme. All right. Now, a little exercise, again, to kind of keep you practicing. But before that, I see that it is 10:26. So that's something that I did not mention at the beginning of the course, but we are going to take a lunch break between noon and 1 p.m. But we also want to take a coffee break at around 10:30 and around 3:30, give or take, in the afternoon. And so I think that because it's 10:26, it's actually a good time to go on our coffee break now. And so we are going to meet back together in 15 minutes, at which time we will do the exercise. So let me, and let's go. All right, so let's correct this exercise together. So first off, we had to make a box plot of the body weight. So for this, we can very quickly go to the documentation, look up online, go quick Google search, and check how we can do that. And you will very quickly find the box function. So px.box, we give the data, we give just an x, and from this we get the following plot, where we have a very simple box plot of the body mass, and the other data is relatively simple. We have the minimum value, lower fence or lower whisker, first quartile, median, third quartile, upper fence, and so on and so forth. So far, so good, relatively simple. Then we can play around and add the y argument to make one box plot per here sex. Okay, so that's what we get. And then if we want to add more things, there are different ways of going at it. So here is the same thing, but now with species. Okay, if we want to add more things, the way that I personally prefer to do it, I find that nicer visually, is to add then something that depends on color. And then you see, for instance, y gives us the species, and then we get two for each species, one for each sex. The other data becomes a bit cumbersome, but at least visually, we have the feed that we want to go for, and we can make all male, all female disappear at once. That can also be useful if we want to focus more on the species by species analysis, or if we want to focus on male across different species or female across different species. An alternative, as I write here also, and perhaps that's how you did that, is to regroup species and sex in a single column. So you can make them a single column or as like some sort of, I don't know, species dot sex or something like that. And then you can just map that to the Y. That's an alternative. Sometimes might correspond better to what you need to achieve in terms of graphical feel. But if you want to go at it quickly, usually that's how I do it. And then to change that from a box plot to a violin plot actually just requires that you change this from box to violin there. Okay, so we just have here that, and then we get this violin. And what I find relatively nice is we see this element there when we can select all the different element there and have this over tool that is quite eventually quite useful if we want to explore a little bit the shape of this violin plot. And then I asked you just to play around and try to make something with ugly colors or with beautiful colors. I just very quickly played around and mapped the different color to here, fuchsia and cyan, which I often find are a bit aggressive to the eye, at least for me. Of course, your taste may differ. I don't really like them too much. And then I also put here the Plotly Dark template so that this pop out even more for more visual aggression. All right. So very, very quick and relatively easy example, I would say, but hopefully that helps you kind of see how we can use the simple concept that we've seen up until now to try and apply them to different kinds of plots. All right. So far, so good. Everything makes sense?